Here are a few additional practice problems for the graphing method of solving quadratics. So with this method, remember we find the discriminant, so we know how many solutions that we're looking for. Then we're going to graph the quadratic function and find the root or the roots, the x-intercept, zero, solution, whatever you want to call it. Alright, so first thing we need to do is find our discriminant. So a is equal to 1, b is equal to 8, and c is equal to 15. So if I plug these in, I have 8, which is b squared, minus 4 times a, which is 1, and c, which is 15. We simplify that using our calculator, and we get 4. 4 is greater than 0, so we are looking for 2 solutions on this one. So now we need to find our axis of symmetry. So we're going to plug in negative b, which in this case is 8, divided by 2 times a, which is 1. That simplifies to negative 4. So our vertex always is on the axis of symmetry, so we know the x value is going to be negative 4. Now we just need to plug that value into our equation to find y. So I'm going to go ahead and plug that in. I get y is equal to negative 4 squared plus 8 times negative 4 plus 15. That's going to simplify down. We're going to have negative 4 squared, which is 16, minus 32 plus 15. Let's see. And that's going to simplify to negative 1. So our y value here is going to be negative 1. So our vertex goes in the middle. We have negative 4, negative 1. We can use our calculator here to find the remaining values for our table. We know we're going to need negative 6, negative 5, negative 3, and negative 2. I could take those x values and also plug them back into the equation and find the y values. I'm going to save a little bit of time here, and I'm going to go ahead and use my calculator. So I'm going to use my table. I get that negative 6 is a value of 3, negative 5 is a y value of 0, negative 4, negative 1, negative 3, 0, and negative 2, 3. I'm going to plot those points, so I end up with negative 3, or negative 6, 1, 2, 3, 4, 5, 6, positive 3, negative 5, 0, negative 4, negative 1, negative 3, 0, and negative 2, 3. And so here I have my parabola graphed, and I notice that there are 2 x-intercepts. They happen at 1, 2, 3, 4, 5, negative 5, 0, and at negative 3, 0. So my x-intercepts here, my solutions, my roots, my zeros, are going to be at x equals negative 5 and negative 3. Alright, now, second example we have here. Y is equal to x minus 3 squared. So first thing we need to do is get this in standard form. So we're going to need to multiply this out. So we have x minus 3 squared, which is x minus 3 times x minus 3. We get x squared minus 6x minus 6x plus 9. Oh, sorry, minus 3x minus 3x. So that simplifies to give us y is equal to x squared minus 6x plus 9. There we go. Alright, so we use those values to find our discriminant. So a is equal to 1, b is equal to negative 6, and c is equal to 9. So I'm going to plug those in. B is negative 6 squared minus 4 times 1 times 9. If I plug that into my calculator, I'm going to get a discriminant value of 0. Okay, so if my discriminant is 0, so it's equal to 0, then I should have one solution. So that's what I'm going to be looking for here, is a one solution where my vertex is going to be on the x-axis. Okay, so axis of symmetry, x equals negative b, in this case is a negative 6 divided by 2 times a, which is 1. We end up with 6 divided by 2, which is a positive 3. And then I'm going to take that x value and I'm going to plug it in to find my vertex. So y is equal to 3 squared minus 6 times 3 plus 9. So I get 9 minus 18 plus 9, which simplifies to 0. Okay, so my vertex here is going to be 3, 0. I also need to find the y values that coordinate with 1, 2, 4, and 5 for my x values. I want to go ahead and plot the points to graph this. So if I put this into my calculator, I have x squared minus 6x plus 9. I'm going to fill in that table of values. If I look down here, I have that 1 is 4, 2 is 1, 3 is 0, 4 is 1, and 5 is 4. So we're going to go ahead and plot those points. So I end up with 1, 4, 2, 1, 3, 0, 4, 1, and 5, 4. Graph those. And I notice that this touches right on the x-axis at the point 3, 0. And so my x here is only going to be x is equal to 3. All right, let's look at another example. On number 3, we have y is equal to x squared minus 2x plus 5. So on this one, I have an a value of 1, a b value of -2, and a c value of 5. So I'm going to plug that into my discriminant. So I end up with -2 squared minus 4 times 1 times 5. If I do the math on this, I end up with a -16 for my discriminant. And so because d is less than 0 in this case, this is going to have 0 solutions. So my answer here should be no solutions. But let's go ahead. We do need to graph it still as part of our practice. So we're going to find the axis of symmetry. So on this one, we have negative b, which is a -2, divided by 2 times a, which is 1. So I have a positive 2 divided by a positive 2, which is 1. So that's going to be my x value for my vertex. I'm going to plug that back into my equation. So 1 squared minus 2 times 1 plus 5, which simplifies to give me a y value of 4. So I'm going to plug that in. I'm going to use my calculator to help me out to quickly get the rest of the values from my table. So I'm going to plug in here x squared minus 2x plus 5. Go to my table, and I need the value for -1, which is 8, 0, which is 5, 1 and 4, 2, which is 5, and 3, which is 8. And I'm going to plot those points on my graph. So I have -1, 8, 0, 5, 1, 4, 2, 5, and 3, 8. And so here is my graph. And as you notice, it never crosses the x-axis. It's going to continue going upward away from the x-axis. So it is a no solution problem. All right, now on number 4, let's go ahead. We do need to simplify this one as well. So let's go ahead and we need to multiply these out. So I have x plus 2. I need to square that. I get x squared plus 2x plus 2x plus 4. Then I also have that -1 out there. But this binomial squared also needs to be multiplied by a -1. So I'm going to go ahead and multiply that by the -1 as well. And I end up with here -x squared minus 2x minus 2x minus 4 minus 1. And when I simplify these, add those terms and add these terms, I get y is equal to -x squared minus 4x minus 5. And that's going to be my equation in standard form. So I have a is equal to -1, b is equal to -4, and c is equal to -5. So I'm going to plug these into my discriminant as well. So when I plug these in, let's see, I have -4 squared minus 4 times -1 times -5. And when I simplify that, I get a discriminant of -4. Just kind of divide that so you can see. So my discriminant here is less than 0, so there should be no solutions on this problem. So my answer should be a no solution. We do need to graph it just to double check. My axis of symmetry, we have a negative b, and our b value here is -4, divided by 2 times a is -1. So that gives me a 4 divided by -2, which is -2. That's going to be my x value for my vertex, and then I'm going to plug that in. So I end up with negative times -2 squared minus 4 times -2 minus 5. All of that simplifies down to the value of -1. So my vertex here is -2, -1. And of course, I'm going to use my calculator. And I'm actually going to just type it in straight in as this format right here, the vertex form. I'm going to do a negative, in parentheses, x plus 2, close the parentheses, square that binomial, and then subtract 1. And I can put in my table. And I see the -2, -1, and I need to do -4, -5. Below that, -3, -2, then -1, -2, and 0, -5. And so we're going to go ahead and plot those points. So I have -4, -5, -3. Oops, I think I went one too far. Yeah, I did. Alright, so sorry. We're going to ignore that first point. So I have -4, -5. We have -3, -2, -2, -1, -1, -2, and 0, -5. And so when we graph those, they all go together. And then I have that one accidental point out there. But here's our graph. Notice it never crosses the x-axis, and it's going away from the x-axis. So it's going to be a no solution, just like we thought. All right, one last final example. We have y is equal to -x squared plus 8x minus 12. So a here is a -1, b is an 8, and c is a -12. So we're going to plug those values in for our discriminant. So we have b squared, so 8 squared minus 4 times a, which is -1, times c, which is -12. And when you work all of that out, you get 16. So our discriminant is greater than 0, so we're going to have two solutions. All right, so our axis of symmetry here, we're going to plug these values in. We have -b, in this case b is 8, divided by 2 times a, in this case a is -1, so -8 divided by -2 is a positive 4. So that's going to be our x value for our vertex, and then to find the y value, we plug that x value in up here. So we have y is equal to -4 squared plus 8 times 4 minus 12. All of that simplifies in our calculator down to a positive 4. So we have x is 4, y is 4. Okay, that's going to be our middle point here. We also need to do 2, 3, 5, and 6. And I'm just going to use our calculator to fill in the rest of that. So our y equals, we have -x squared plus 8x minus 12. We go to our table. Let's see, 2 is 0, 3 is 3, 4 is 4, 5 is 3, and 6 is 0. That's what we're going to plot. We have 2, 0, 3, 3, 4, 4, 5, 3, and 6, 0. And when we graph that, we see our parabola. We have two x-intercepts, one at 2, 0, and the other at 6, 0. So we end up here with 2 and 6 as our solution.